Hi everyone, this is Vignesh. Welcome to the tutorial series on compiler design. In this series, I'll be explaining about some of the practical implementation of how to design a compiler. So I will not be able to explain the theoretical background of this. So I think there are a lot of resources that you can find online, but the problem is we don't get to know about the practical explanation about, like, there are no good resources, no good practical resources online for this subject. So that is the reason that I started this series. So I hope you get something out of this or get some idea about how to start off with this design. So if you have any questions, any theoretical questions, please comment down below and I'll try to answer them as much as I can on the upcoming videos if time permits. And also this video will be this series will be explaining mainly about how to design the compiler in terms of uh, several phases. I mean, like the lexical analysis, syntax, semantics, and code generation. So I'll be doing this in a Windows environment and using Lex and Bison for compiling. And the tools that I'm going to use is Lex, Yak, and then C programming language. For different operating systems, I'll try to explain how to compile things in different operating systems on a different video, but for now I'll be going forward with Windows environment. So without doing any further delay, I'll start off. So basically, I hope Flex and Bison is pretty much straightforward to set up on your machine, and there are some other videos which explains about installing and setting up Flex and Bison, and I think those can be done as a prerequisite to this video. So I'll start off with the coding part. So first of all, so when we start off with the lexical analyzer, we need a lex file, right? So I'll create a lex file here. Um, Let me name it as example.l. So lexical extension is .l. So this lexical analyzer would have several sections inside it. So, like, first one is the includes. It's pretty much like how a C program works. So in C, we start off with includes and other several inputs that we are going to use, the header files or else the standard libraries that C uses. Following that, there will be some definitions which are related to this lexical stage, such as types and so on. And then there will be some rules or regular expressions to match, to check, to validate the tokens, the lexemes which are going to come inside this phase, and the relevant actions if such conditions are met. And finally, there will be a section to write a C program, means custom user programs or subroutines. So this will be handling some of your so-called functions or implementations, or whatever you want to do using C language or C++. So in this series, I'm going to do using C, but there are some examples with other languages as well. So these will have these subroutines will be like, printing or validating or something. Obviously, it'll start off with the main method, but following that you can write any number of functions as you want, as per your requirement or whatever. So these are the four main parts of a lexical file. So let's start off how it goes. So the initial includes phase will be so between these two tokens. I mean, like percentage open parentheses and percentage close parentheses. Within these two symbols, you have to write down the includes or inputs. So for now, I'll just start off with standard library. Okay, stdlib.h. So if we need, as per we want to do, when we go further, we might have to use several others, like for strings or IO or something. So we may have to use several inputs, but for now I think this is enough. And next, There'll be some definitions, and for now I can skip this. I'll explain that a bit later. Um, inside this section, we'll be having our rules, or like regular expressions of for the tokens to be matched, and I'll come to this part. And finally, there is as I said, there here is where we're gonna define our subroutines or the functions that which are needed to as per our requirements. So the first thing that comes to our head when writing a C program is the main method. So let me write that. So inside the main method, I am going to write yylex. So yylex is nothing but a function call which calls this lexical analyzer to start off like to do the lexical analysis. And following that, we might need ywrap. So ywrap is nothing but we can call it as an interrupt to stop this process if there is no more uh, no more tokens in the file. I mean, like this would ideally return one if there are no more token. It's like if it is the end of user input, and it'll return zero if there are any inputs. All right. So that is about this section. And then so let's define. Okay, so let's see what sort of regular expression that we are going to use. So um, let's see, like in this program, so let me just start off simple with identifying a word called program. Okay, so simply as that. So this is I'm going to say if this is the string that you are going to find, this is the token that you're going to find from the user input, and if you find that, do me a favor. All right, do me something like this. So printf, I can ask this lexical analyzer to do something for me if you find this token. So it's not limited, you can write as much as you want. So if it's a single command, then I think you can write like this. If there is anything more to do other than this, you can write it with, inside the semicolon, and you can write on whatever the function you want and call. So I'll go with printf for now. So I'm gonna say, okay, hey there, I've found program from your input. So if the lexical analyzer finds this token, it's going to say, hey there, I found the program from your input, found program token from your input. So this is simply one of the basic lexical functions that we are going to see here. Okay, so let's try to compile this and see. Okay, so compiling is a bit tricky part. It includes several phases. So in this I have installed Flex. So in your based on your operating system, you might use different libraries for like Lex or something. So based on that, these command might slightly change, but the principle is same. Actually, what happens behind the scenes is always same. So here, first of all, to compile this file, I'm gonna run flex example.tel and press enter. Okay, if you see, after I compile the lexical file, so you will see there is a new file generator called the lex.yy.cc. This is one of the output files uh, that generates after compiling a lex. And then using GCC compiler, I am going to again write another uh, instruction to write another command to compile this output file. So I'll type lex.yy.cc. Okay, so what I've done here is I've just typed this starting part of the name and press tab, so it'll take the name as it wants, and then press enter. And now you see this is also okay, and on my left side there is a lex.yy.o file generator. Now using these two files, let me get the ultimate output. I'm going to create an exe file, which is in order to execute this program, and that will be done as this. So gcc.lex.yy.o, and then as my output, I'm going to name it as example sample.exe. Simple as that. So when I type enter, all right, an example.exe file has been generated on my left side. So let's run this program and see. Example.exe and press enter. Okay, there are a bunch of errors coming out. Let's see. It's all right. You can't run it in this way. So in Windows environment, you have to run dot and backward slash following by the name of the executable file and press enter. So now when I press enter, there's nothing. It's going to a new line, and it's asking for our input. So let me try writing the token which I've mentioned here as the program. So let's see whether we are getting the expected output and press enter. So if you see, when I type the word program and it has identified, okay, I found program, and I'm gonna print, hey there, I found the program. I found program from your input. So that is the expected behavior, right? So it's working as expected. So when I type something else, it's gonna say, it's gonna repeat what I said. It's gonna write like hello world, and it's gonna say whatever, like it's gonna be repeating what I'm gonna say here. So we can there is a way to control this. Actually, let me stop this. There's a way how we can control this using, there's another regular expression that we can write here to stop. There is, we have to press dot, and following that we can say, okay, printf um, um, not valid input. So this is the, this is what it's gonna say. So let me compile this again. So flex, and then flex, and then finally gcc. So now let me run this exe file. So again, if I type program, it's gonna say okay, and then if I type hello, it's gonna say not a valid input. All right, it's gonna say for everything. All right, so what's happening here is actually for each and every tokens for HELLO, it's typing the output as well. Okay, interesting feature, isn't it? If I type a single letter, it does. So we can control this as well. So there is something called YY error. Let me show. So there is something called YY error. There is a method, so YY error, and as an input to this, we are going to get a char pointer. So we can string of just put it as, and then following that we'll say fprintf std out, and say okay this, and then we are going to say to exit the program once an invalid output is found. Let's compile it and see. Okay, flex is okay. GCC, okay. Okay, we forgot one thing. We have to, without doing this, we have to call the YY error from here. Okay, let me redo. Now what? Previous declaration by YY was there. Okay. I think the way to solve is declare the YY error. As I said, here goes the declaration, and how you declare YY error is char and the pointer symbol. Okay, I think this should solve. Okay, that works. And then the final command is this. Let me run example again. Okay, so let me type hello, not a valid input, and the program exit. So this is what we expect, right? So if we give a valid input program, it asks for the next, it waits for the next user input, and if we give non-valid, invalid input, um, whatever, and you get another valid input, and the program terminates. So this is the basics. This is the basic of lexical analysis, and on my next video, I'll gonna be explaining about how to uh, write regular expressions for identifying different types of inputs. So it may be numbers, strings, and factors, decimals, and so on. So we let's see how we could write different regular expressions, and also we'll see how we can uh, take this token and do some other processing to go to the next step, which is the syntax analysis. So I hope you enjoyed this video. If you have any concerns or if you have any doubts, please put down on your comment section. I'll try to explain as much as I can. And all right, thank you very much. Stay tuned and see you in my next video. See you. Peace out.